All right, we're now ready for lesson 10.2, and we're still working with these trig identities. And go back to our first slide. That's the lesson, verifying trig identities. And so just a couple of helpful hints, steps that you're going to be needing to follow. Number one, as I've listed here, simplified one side of the equation. I'm going to do some examples of this, but my first few examples will only be focusing on one side of the equation being simplified. And here's a tip. It's often easier to work. It's kind of ironic, but it's often easier to work with the more complicated side. So in other words, with these first few, I'm basically working on the side that I feel like is the more complicated, and I'm going to make it look like the other side. So just to take this first example, for instance, on the next slide, I'm going to turn this left side using identities so that it looks like the right side, okay? Because it looks like it's more complicated. So we're going to transform that expression, which, talking about the more complicated side, into the form of the, I guess you would call this the easier side or the less complicated. All right, so let's just take a couple of examples here. So this is that same one I had on the previous slide. So I just listed the Pythagorean identities as a review. We talked about those extensively in lesson 10.1. So conforming this left side so that it looks like the right side is the goal. So I'm going to begin with this first Pythagorean identity. I can replace sine squared theta with 1 minus cosine squared theta. And typically what will happen is, as you work your way through this, you just do a little question mark. It's kind of like a proof, and we're working our way to make these two sides equal each other. Okay, and now focusing still on this left side, I notice that the numerator is the difference between two perfect squares, so I can factor. And rewrite the denominator. Still working toward the goal of making in this case, the left side match the right side. Okay, now that I've got it broken up into factors, I can cancel. And here I have it. I've got the left side matching up with the right side. And there's an example of the type of thing that you're going to be doing in lesson 10.2. Okay, here's another example. So once again, just as a reminder, went ahead and put these up on the screen for you, but you really need to get very familiar with these, as well as all of the identities, but especially these Pythagorean identities as you work your way through these problems. Okay, so let's see what we got here. We've got cotangent squared minus cosine squared theta is equal to the right side. So I'm going to take the same approach. I'm just going to work on changing this left side of the equation into the right side. All right, so I'm going to use the identity that says cotangent is actually cosine divided by sine. It's a quotient identity. And the goal is to make that side equal this side. Okay, and I'm going to work on a common denominator here on the left side, which is obviously going to be sine squared. So this first fraction does not change. But if I make this denominator also sine squared theta, then remember it's denominator, which is 1. 1 divides into sine squared theta, and then it's sine squared theta times, and then you multiply times cosine squared. Okay, so now we can put these numerators together, and notice that when we subtract, the cosine squares are going to cancel each other out. Let's go ahead and list this out. I'm actually going to do some factoring. Okay, so we can cancel these out by factoring out the GCF of cosine squared theta. So if I factor out cosine squared theta from this, I get 1 minus sine squared theta over sine squared theta. Still working on making that look like. Notice I haven't done anything to the right side, just been focusing on the left and trying to make the left side equal the right side. Okay, so far so good. So I know from this Pythagorean identity, I'm running out of space here, so see if I can squeeze it in over here. If we manipulate this first identity, we know that cosine squared theta is 1 minus sine squared theta, so I can replace 1 minus sine squared theta with cosine squared theta. So let me just put this on the next slide. I think that's right. Yep. Equals cotangent theta squared and cosine squared theta. Okay. All right, so we can replace this with cosine squared theta. Okay. All right, so what we have here, if we divide cosine squared by sine, that's how we get the cotangent. Okay, so we just divide here, and this would be the, I'll just go ahead and write it out. And then we'd be multiplying by cosine squared theta. And so that's one step closer to getting there. So obviously you can see how this is cotangent. And now we can say it equals. So it's a good exercise in really getting familiar with all of your identities. All right, let's try another one. This one's a little bit easier probably. Verify that this is an identity. So obviously I'm going to take the left side and make it equal to the simpler side, the easier side, which is 1. So let's think about cosecant is 1 over sine. And tangent is sine over cosine. And we want to, we're forcing or making the left side come out to be the right side. And since we're multiplying all these together, we can do some canceling. So those cancel, This one was pretty nice. So 1 equals 1, and we are done. Okay, let's try this one. This one's not quite so nice. So I'm going to focus on, this looks kind of complicated here, so I'm going to be focusing on this right side, making it look like the left side. Okay, and I think since this one's going to take, I already know, I've got another slide ready for this one. I'm not going to just keep writing this left side every time, but just know that I'm going to try to make the right side equal the left. Okay, so for now I'm just going to be focusing on the right. So we have this binomial squared. So remember how we talked about, we can do that mentally. So square the first term. And then these two times each other times 2. Okay, so if you wanted to write this down twice and use FOIL, that would be perfectly okay, but this saves the time from doing that. And then we square this last term. All right, now I'm going to think about getting this into a form, some sort of consistency here. So I know cosecant squared, going back to one of our identities. If you remember, I'll write this out and then erase it. Remember the one that says cotangent squared plus 1 is equal to cosecant squared. So that means that in place of cosecant squared, I can substitute this, cotangent squared theta plus 1. So I'll just put parentheses around that to show that this got substituted. All right, and then I'm just going to keep on working to the right. I'll just go ahead and bring this down, and then we'll look at some other things that we can do in just a second. Here we are again with cotangent squared. So all right, so let's see. Let's think about cotangent, both of these cotangents as cosine over sine. And cosecant is 1 over sine. So these are all being multiplied together. Here's cotangent again, cosine over sine. And once again, cosine squared over sine squared. All right, so you can kind of see how we're going to have a common denominator because when I multiply, let me just go ahead and do another step here. When I multiply these together, 2 times 1 over sine times cosine over sine, that becomes 2 cosine theta all over sine squared theta. Okay, and so we're all pretty much all consistent except obviously right here, and 1 would be sine squared theta over sine squared theta. So I'll just go ahead and rewrite it. Just wanted you to make sure you understood where the 1 is going. I'm just going to make it into sine squared over sine squared. Okay, give me a second. Okay, now we're ready to take this, and I'll go to the next slide, and we'll just make it into one fraction and then start cleaning it up a little bit. So it's going to be, our one fraction is going to be cosine squared. And then let me just go back here. I can, since these are all cosine, I can think of that Pythagorean identity that says sine squared plus cosine squared equals 1. And I can replace sine squared with 1 minus cosine squared. So that makes it uniform in the numerator. So this is going to be 1 minus cosine squared theta minus 2 cosine theta plus cosine squared. And that's all of my numerators, and it's all going to be over, well, let's just go ahead and make that change too. It's all over sine squared theta, but since the numerators are in terms of cosine, we can do the same thing down here. We can replace sine squared theta with 1 minus cosine squared theta. Okay, looking good. All right, so let's see what we got here. Cosine squared minus cosine squared, those are going to cancel. So combining like terms, see if this makes sense to you. Combining like terms in the numerator, I'm going to have 1 minus 2 cosine theta plus cosine squared theta. These would cancel, but I've still got this one on the end, over 1 minus cosine squared theta. Okay, we're almost there. This one's kind of a bear. We're going to factor the numerator. So think about how you would factor a quadratic trinomial. I know it's kind of backwards, but it's a little bit easier when we start canceling with the denominator if we just leave it in this form. So we're going to have factors of 1 here. Both are going to be minus. And then to make cosine squared on the end, it's going to have to be cosine theta in both cases. So if you wanted to test yourself out, you could do FOIL. And if you did FOIL on these two, you would get this numerator. And then the denominator is the difference between two squares. So it's 1 plus cosine theta times 1 minus cosine theta. And you can start to see now where it's starting to come together. We can cancel. And we're left with, going all the way back to the beginning, our left side was 1 minus cosine over 1 plus cosine. And so we made the right side equal the left. Okay, that one was a lot of work. Okay, let's try this one. This one's really not too bad. We're gonna, obviously there's more going on here on the left side than there is the right, so I'm gonna make the left side look like the right side. So if you do tangent times cotangent, obviously those are reciprocals, so that's just 1. And then if you think of tangent as sine over cosine, so let's just do, it's going to be the distributive property, sine over cosine times cosine squared. Okay, so I distributed the tan squared to cotan squared and got 1, and now I'm distributing tan squared in the form of sine over cosine. And so I just wanted to illustrate how that's just going to become sine squared. Okay, but before I erase it, I just wanted you to see where it came from. So multiplying tan squared times cosine squared gives me sine squared. And the goal is to see if that equals the right side. And if you think back at your very first Pythagorean identity, that's basically what it says. Sine squared plus cosine squared equals 1. So if you do 1 minus sine squared, you get cosine squared. Okay, we're almost there. A few more examples of where we're actually going to transform both sides. But I need to give you a few little tips and hints, and well, some are suggestions and some are just things you need to keep in mind mathematically. You're still substituting trig identities. That's still true. Factor and multiply just like you did before. If you can, try to get the sides in terms of sine and cosine only, and then simplify each side as much as possible. This is a big one, though. Some people forget. You really don't want to treat these as normal equations, algebraic equations, where we do this operations on both sides, like dividing both sides of the equation or adding or subtracting. That's not the same thing we're doing here. So stay away from performing operations on each side of the equation, because basically we haven't truly verified this identity yet. It's not an equation necessarily. It's we're trying to prove an identity. So here we go. Let's take a look at this one. All right, so actually on these, I'm going to be working on both sides to try to make them agree. I'm going to do some factoring, because on the left side, I notice that this is the difference between two squares. Okay, and then I can factor on the right side as well, factor out secant squared as a GCF. Okay, and looking back at our Pythagorean identities, I just went ahead and listed them again here for you for reference. Notice that 1 plus tangent squared is equal to secant squared. So we can substitute secant squared. And we can also, with a little manipulation, if you notice that tangent squared is the same thing as secant squared minus 1. Okay, do you see how that, if I just subtract 1 from both sides? So here, in place of tangent squared, I'm going to replace it with secant squared theta minus 1. Okay, now let's see what we have over here when we clean this up a little bit. Secant squared theta. And again, if you just drop the parentheses, it's like negative or minus secant squared theta plus 1. Should be doing little question marks here. Okay, and now you can kind of see it taking shape, because in the parentheses we've got 1 plus 1, which is 2, minus secant squared theta, and that does match our other side. So we're done with that one. Okay, hopefully that helps. Just take some practice. All right, let's take a look at this one. So for this one's not too bad. Cosecant, you can think of that, thinking about your identity. Remember the identity that says cotangent squared plus 1 equals cosecant. Well, since this one's already in terms of cotangent, let's just replace this with cotangent squared theta plus 1. Okay. And you can kind of see how that's going to be beneficial. And on the right side, these are reciprocals, so that's pretty easy. Cotangent times tangent is just 1. And we can make the cotangent squared minus cotangent squared is 0, and 0 plus 1 is 1. So some of these are pretty nice. They're pretty straightforward. This one, however, is not quite so much, but it's not too bad. Let's go ahead and we're going to transform both sides of this. So I'm going to think of cosecant in terms of 1 over sine, and secant as 1 over cosine. And instead of cotangent, since these, again, think back at that list that I gave you, if you can, it's not always possible, but if you can write everything in terms of the same trig functions, that makes these quite a bit easier. So in terms of sine and cosine, let's rewrite cotangent as cosine theta over sine theta. Okay, so if I get a common denominator, which would be sine times cosine, then this would be cosine theta. And this would be sine theta. So the left side would be just cosine theta plus sine theta all over sine theta cosine theta. All right, and then on the right, dividing by cosine is the same thing as multiplying by 1 over cosine. So we'll think about it like this. So just distribute 1 over cosine times 1 plus, and this would be cosine over sine theta cosine theta. All right. And do you see how in this fraction you could cancel out the cosines, and so it's just 1 over sine. So basically we're back to what we had over here if you cancel these. And so we could go through that exercise again of converting these to the common denominator, but we did that over here already. So I would just at this point just show that they're the same. And up in this point, we were questioning whether they're the same, but it turns out that they are. Okay, let's see. Oh, that's it. That's our last one. Okay, not too bad. So those are the problems that we're going to be working on. So hopefully I've done enough to help you, but if not, if you have any questions at all, reach out to me and I'll be glad to help you.